In this video, we will look at section 6.5, which is on inequalities and absolute values. We have two sets of inequalities: weak inequalities, where the value that we receive is included, and this is denoted by smaller or larger and equal to, or smaller and equal to. And we have strong inequalities, where the value is excluded, and this is denoted by larger and smaller signs. We indicate an inequality by we indicate an absolute value by two vertical lines. So if we have some value n, the absolute value is indicated by n between two vertical lines. The definition of an absolute inequality is that it's equal to negative n if n is smaller than 0. It's equal to positive n if n is larger than 0, and it's equal to 0 if n is equal to 0. So what are the rules of inequalities? First, if a is larger than b, a plus k will also be larger than b plus k. If a is larger than b and we multiply, ka will be larger than kb if and only if k is larger than 0. Ka will be smaller than kb if k is smaller than 0. If a is larger than b, a squared will be larger than b squared. Our rules for absolute values: if we have m, the absolute value of m plus n, this will be larger or equal to the absolute value of m plus n. If we have the absolute value of m times the absolute value of n, this will be equal to the absolute value of the product of mn. If we have the absolute value of m divided by the absolute value of n, this will be equal to the absolute value of m divided by n. So let's look at some examples. Suppose we have 4x plus 6 is smaller than 4. How do we solve this? We simply say 4x smaller than plus 6 becomes negative 6. And then we divide. So 4 minus 6 is minus 2 divided by 4. This is equal to minus a half. So x is smaller than negative a half. If we denote this in set, it means x, given that x is smaller than a half. And in bracket forms, x can be anything from negative infinity to negative a half. These brackets indicate that the value is not included, so there's no equal sign here. If we have 4x minus 2 smaller equal to 2x plus 8, again 4x minus 2x must be smaller equal to 8 plus 2, taking all the unknowns to the left and constants to the right. That means 2x must be smaller equal to 10, which means x must be smaller equal to 5. In set notation, this gives us x given that x is smaller or equal to 5. Again, we can have x any value from negative infinity to 5. However, in this case, it can also be equal to 5, which means we have a square bracket. And an absolute value, say the absolute value of 4x plus 8 smaller or equal to 16. We change this into a normal inequality, so 4x plus 8 smaller or equal to 16, but it must be larger or equal to minus 16 because of the absolute value. That means 4x must be larger or equal to 16 minus 8, must be minus 16 minus 8. Larger or equal to minus 16 minus 8 and smaller or equal to 16 minus 8. That means x must be smaller or equal to 8 divided by 4, and it must be larger or equal to minus 24 over 4. That means x must be larger or equal to minus 6 and smaller or equal to 2. In set notation, x, given that x is larger or equal to minus 6 and smaller or equal to 2. In our bracket notation, this means minus 6 and 2.